Hello guys, so today I'll be explaining the physics quiz of term 1 week 4. So let us start. Which of the following are true about fossil fuels? Now fossil fuels, okay, just a quick summary about them. We should save the fossil fuels for future generations, okay? And if we use up all our fossil fuels currently, we will increase the effect of greenhouse, or the greenhouse effect. Okay, what is the greenhouse effect? It is caused by two main gases, mainly water vapor and CO2. There's also a little bit of CFC. Now the water vapor traps the most infrared. The water vapor traps the most infrared radiation. Okay, the CO2 traps the least infrared radiation. Okay, and the CFCs, they trap what? They trap infrared electromagnetic waves. So infrared electromagnetic waves. So what about the fossil fuels? Fossil fuels, they should not be used, okay? They should be conserved. They're important for plastics and man-made medicine. We have to save the fossil fuels for future generations because it's not fair for us to use everything up. Okay, fossil fuels are also a limited resource that deplete over time, and I just described about the greenhouse effect. Another thing, in 50 years the Earth's temperature will rise between 2 to 5 degrees Celsius because of the greenhouse effect. And what is the greenhouse effect? It's basically, this is our Earth, this is the ozone layer, okay? This is the sun, it's emitting, this is infrared radiation. Now, usually the infrared radiation will go, warm the Earth and bounce back. Some of it will stay, usually. But with the greenhouse effect, we are putting CO2, water vapor, the CFCs, okay? And what is it doing? It's causing the infrared to stay in the Earth. So this is another infrared. Instead of going back to the sun or bouncing back, it will continue and it will come back to the Earth. So the Earth's temperature will increase gradually. That's why they're saying in around 50 years, the Earth's average temperature will increase by 2 to 5 degrees Celsius. Now, which of the following are true about fossil fuels? Fossil fuels should be used and not conserved. No, they should be conserved and not used. They're an important source of plastic. They are limited resources that deplete over time. It's unethical to have fossil fuels available. No, we need to have them available for future generations. And fossil fuels are important sources of man-made medicine. Now, question number 2. Which of the following substances contribute to the greenhouse effect? We stated them before. We said water vapor and carbon dioxide and the CFC gases. So nuclear waste doesn't contribute, CFC does, carbon dioxide does. Sulfur dioxide dissolved in water produces acid rain, but it doesn't contribute to the greenhouse effect. So it is only CFCs, carbon dioxide, and water vapor. Number 3. Choose the correct answers to describe the energy transformation in each of the cases below. During the burning of coal, what is transformed into what? So coal, it stores what in it? Chemical energy. So whenever you see burning, it's gonna transform the type of energy that was originally in the substance, in this case coal, it will transform it into thermal energy. So for the first one, the coal will transform chemical energy into thermal energy. Now, during fission on the sun. What happens during fission? Fission is a nuclear reaction, so it contains nuclear energy. So what happens? The nuclear energy on the sun, okay, it will form what? Light or radiant energy. So what's happening? The nuclear reaction happens, which is nuclear energy, and then it will give us the light of the sun. So nuclear energy will give us light and radiant energy. Now question number 4. This is very important to memorize the table. Okay, I will write it here. We have first radio waves, then microwaves, then we have infrared, then visible light, then we have ultraviolet, then X-rays, and then gamma rays. Okay, as you go down like this, what increases? The frequency increases. But as you go up like this, what increases? The wavelength increases. So memorize, when you go down, the frequency increases, and when you go up, the wavelength increases. So what has the maximum frequency? We said as you go down, it has a greater frequency, so definitely gamma, and then ultraviolet, and then infrared, and then radio waves. Now question number 5. We said before, as you go up, so starting from gamma all the way until the radio waves, the wavelength will increase. So that means the radio waves have the greatest wavelength and the gamma rays have the smallest wavelength. You don't have to memorize these, you just have to understand. Gamma rays have smallest wavelength, and not infrared, and the radio waves have the largest wavelength. That means, which is the biggest number out of all of them? 1 kilometer. After radio waves, we said there was microwaves, then infrared rays. Okay, so the infrared should be a little bit smaller than the radio waves, so definitely 1 millimeter. And then the visible light comes after the infrared, so it should be smaller than the infrared, so probably 1 micrometer. And then finally the X-ray, which is like after visible light we have UV and then the X-ray. Now the X-ray is definitely the smallest one because it is the one that you like, the last one. Now, chemical energy in gasoline, burning fuel. Now, drag and drop the correct statements to complete the energy chain that describes the working principle of a water pump. What happens? You have energy in the gasoline. When you burn this chemical energy, what will happen? It will be transformed into electric energy in the wires. Now, the electric energy of the wires in the generator will cause the generator to rotate. So now there is rotational energy in the generator. After that, what happens? The water will move with the generator. So now the water is moving up, up, up. And finally, since it is high above the ground level, it's going to have gravitational potential energy. And of course, there is heat loss. Now, question number 7. Okay, please memorize that the fossil fuel that produces the least amount of CO2 is coal. A hybrid car runs on what? Multiple types of energy. So it can run on electric energy, and it can run on gasoline, and it can run on batteries. So like, remember, a hybrid car can use multiple sources of energy, so it can also run on gasoline. And the least damaging fossil fuel, the least bad fossil fuel, is natural gas. Question number 8. Which of the following are achievable effective methods to reduce the fossil fuel consumption? This is very important. To reduce the consumption of fossil fuels, we can use solar energy. Okay, we can burn fossil fuels. So this is burn fuels with less, not the E, with less CO2 production. Okay, so this is 1, this is 2. And then we can increase car efficiency, so we use different types of cars, like hybrid cars or electrical cars, and that's pretty much it. Okay, so also another way is to bury the CO2 underground. They didn't mention it, but for example, if you're producing a lot of CO2 and instead of sending it up to the atmosphere, you can send it down into the ground, so then it will help with many other stuff. Which of the following are achievable effective methods to reduce fossil fuel consumption? We said switching to hybrid cars, so increase car efficiency. Burning fossil fuels that give out less carbon dioxide per energy. We didn't say anything about insulating power plants. We didn't say substituting all fossil fuels. We do need fossil fuels from time to time. Okay, it's important to use them. And finally, increasing the consumption of natural gas relative to oil. Relative to coal, sorry, because natural gas is the least dangerous fossil fuel. Now, which of the following is true about a photon? Now, a photon, okay, the energy is directly proportional to the frequency, and it is inversely proportional to the wavelength. So just memorize it like this. Energy is directly proportional to frequency, and it's inversely proportional to wavelength. Another thing is that yes, they can have wavelength and they can have frequency, and the color depends on how much energy you have. So we said the energy is proportional to the energy is proportional to or depends on its frequency. We said the color depends on its energy, okay? And we also know that energy is inversely proportional, not proportional, and we know that photons can have wavelengths in the visible spectrum. So energy is inversely proportional to wavelength and directly proportional to the frequency, or you can say it depends on the frequency. Which statements describing infrared radiation are false? There are some things we need to know about infrared radiation. They are given off by hot bodies, but not only hot bodies. There are many other sources. They are mainly given off by what do you call it? Motion. So when you're moving, infrared radiation will be given off, kind of. Okay? So anyways, in this question, what statements describing infrared radiation are false? We said infrared radiation is given off by hot bodies only. No, it's not only given off by hot bodies, by other types as well. And it can be harmful to our skin. No, infrared radiation isn't harmful to our skin. It's the UV light that is very dangerous to our skin. Now, this means that infrared photons possess less energy than visible red light. That is very true. And molecules undergoing random motion occasionally radiate infrared radiation. This is also true. So that means infrared has less energy than the red light. If it has less energy, that means it has less frequency, but it has more wavelength. Okay? Molecules undergoing random motion. So anything that does a random moving, that moves, okay, it radiates infrared photons. And finally, infrared radiation affects certain types of photographic film. This is true. So which are false? It's not only given off by hot bodies, and it's not harmful to our skin. Question number 11. The name given to the types of energy related to position and motion. Anytime you see position and motion, or potential, or the sum of potential and kinetic, or kinetic, however you say, okay, this is called mechanical energy. Question number 12. Sound is given off by what? By vibrating bodies. So for example, take in a guitar. I can't draw a guitar, but I will draw a circle, okay? And I will draw some strings. This is the string, like the thingy of the guitar, okay? How do you make sound from the guitar? When you pluck it, it will move back and forth. So it is what? Vibrating, Okay, so this vibration gives us sound. Another example is our chords, our vocal cords. They vibrate. So when we are talking, the vocal cords are then vibrating, and so they produce sound. So vocal cords also vibrate, and so they produce sound. So any vibrating body produces a sound. For example, take any string and stretch it, or if you have a hair tie, take a hair tie and stretch it. If you flick or you pluck on the hair tie or the string, it's gonna make a sound because it's vibrating. Now, sound energy may be defined as alternating. Now, anytime you see alternating and sound energy, remember, it is the change or alternation between kinetic and elastic. What does it mean? Let's take the example of the guitar again. This is our guitar. We have the chords over here. If we pluck it, first of all, the string is elastic, yes? So if we pluck the string, okay, it's gonna move. This motion is kinetic energy. And because it's elastic and kinetic, it is a change between the elastic and the kinetic energy. So we call this sound energy from the vibrating systems. Now, match each action to the energy conversion taking place. When you turn on a light bulb, what happens? The electric current will go and produce light. So that is electrical energy into radiant energy. Charging the battery of a car. When you're charging anything, the electricity is coming in your phone. So whenever you charge the phone, the electricity is gonna come in, okay? So anytime you see the word charging, it's electrical, and anytime you see battery, it is chemical. So it's gonna be changed electrical into chemical. When you apply the brake, what do you do first? First you press on the brakes. When you're pressing, this is mechanical energy, and then the car stops. And what releases? Sound and heat. So that's why when something fast hits the brake or the car hits the brakes, there will be a lot of heat surrounding it. So applying the brakes is mechanical into thermal energy. Now, burning a candle. What happens when you burn a candle? A candle is chemical. Okay, remember, candle is chemical energy. What does it produce? It produces a light. So it changes what? Chemical energy into radiant or light energy. Question number 14. As we said, the energy increases as the frequency increases, so we have to order it from least frequency to most frequency. So we said first the microwaves, first the radio waves. I didn't see. First the radio waves, then the microwaves, then what's after it? We have the infrared, then the visible light, then the ultraviolet, and then the X-ray and gamma ray. Please memorize it, it's very important for the exam. Now, which of the following statements are true about the greenhouse effect? What is the greenhouse effect? We said it is a heat trapping, okay, due to CFC, water vapor, and CO2, okay? So, first of all, the greenhouse effect is a recent phenomenon. It's not so recent, but it's not caused solely by human activity. It's not caused only by human activity, okay? Next, the heat trapping effect of atmosphere is mainly due to its oxygen content. Oxygen is not one of the gases we stated. We stated CFC, we stated CO2, and we stated water vapor. So, heat trapping due to the oxygen content is not one of the what is not true about the greenhouse effect. Then, greenhouse effect results in increasing the temperature of the atmosphere. This is 100% true. Also, heat trapping properties of atmosphere are due to the absorption of radiant energy by its gases. Yes, we have the carbon dioxide gas and the water vapor and the CFC. They all absorb radiant energy, more specifically infrared energy. Okay, each one by like a specific amount, you know? So water can absorb the most or high amounts, and the CO2 can absorb the least amounts or low amounts, and the CFC can absorb a medium range amount that no other gas can absorb, only the CFCs. So here, CFC gas is capable of trapping a middle range of infrared electromagnetic waves in the atmosphere. That's for 15. Now for 16, this is also very easy. They're telling us match each device to the type of energy conversion it performs. We have a candle. We said in a candle what happens? We have chemicals in the candle. The chemical is chemical energy, and then it produces what? Radiant energy. So it changes chemical to radiant energy. A photographic film, what does it do? First of all, when you're taking in the photographic film, you're gonna be taking a picture. So it's gonna be changing the radiant energy, okay, more specific, the gamma, okay, into chemical reactions that will produce the picture. So it's gonna be changing radiant to chemical. A stick of dynamite, okay, it's an explosion. If you know that in the stick of dynamite it is chemical, so the explosion, what happens? Lots of light, lots of sound, and lots of motion. So anytime there is lots of sound, lots of motion, anything with kinetic and potential energy, it also has potential energy, because chemical potential energy and there is kinetic energy that happens after the explosion, it changes what? Chemical to mechanical energy. Now a photocell, what does it do? It takes in the radiant energy and it changes it to electric energy. A photocell is basically a solar cell that will take the energy, the sunlight energy, and make it into electricity. Finally, the steam turbine. When you are heating the water, the particles are gonna be moving faster. So this is thermal energy, okay? And it's gonna be changed into the motion of the turbine, which is mechanical energy. And so then we have an electric heater. What does the electric heater do? From its name, it changes electrical to thermal energy. So let's submit and see. Thank you guys for watching. I hope you understood and have a great day.